Hi everyone, we're going to go over some practice demand shift problems. So make sure you have your paper with the graphs that talk about the different shifts for hamburgers, and let's go over them. So you should have this paper here in front of you. And if you notice that I have given you the acronym TRIBE over there in the corner as a reminder. That is the acronym that I like to use to help remember the shifters. You should not be doing this assignment if you have not done the assignment where you really dig deep into the different shifters in demand and what causes the demand curve to shift the way that it's shifting. But here we go. So for example, number one, let me pull this up. So example number one says we have a population boom. So this could be a couple of different situations. This could be literally you have more people being born, like the baby boom after World War II, or maybe you have more people moving to a particular place. So maybe a particular country is having an increase in immigration, or it might just be that there's a particular region of a city or of a country that had a smaller population, and then for whatever reason, more people are growing and moving to that area. Like St. Johns County, when I was in high school, literally nobody lived there. And now you have all these new cities. And so where the people go, so will go the businesses to serve that community. And so we have a population boom. So let's ask ourselves, if we have a population boom, that means we have more people. Let's say, for example, it's the weekend of the Daytona 500 in Daytona, and the restaurants there um, are going to see a significant increase in the population, or the way that I phrase it on the sheet is the number of buyers. Literally, how many people are buying this product? So you could call it population, or you could just call it number of buyers. And so if it is Daytona 500 weekend in Daytona, you're going to have an influx of thousands of people going to the city. So if you have thousands and thousands and thousands more people than normal, what do you think is going to happen to the number of hamburgers that you're selling? So we look at the situation and then ask ourselves a couple of questions. Number one, is this going to mean that we are more people want hamburgers or fewer people want hamburgers? And if we have a population boom, that means more people want hamburgers. So if we're having more people, then that is going to give a shift in demand to the right or an increase. I know sometimes in that video they use those terms interchangeably, that the graph would shift up or it would shift right. I do not like talking about supply and demand shifts with thinking about up and down. I think it makes things confusing. So instead, what I would like for you to do, I have already given you a pre-drawn graph. But these graphs are incomplete. So the first thing that we need to do is come up here and draw a P for the price to label the y-axis. You could do that with all of your graphs right now. And then the Q for quantity is already there. But take your finger, right, and put it on that dot that we just drew. So if I am thinking about an increase in demand, I like to think about increases and decreases the way you would think about a number line. So if this is 0 and I'm moving this direction on the number line, an increase means that we're moving to the right, and a decrease means that we're moving to the left. So in this case, if we are moving to the right, then we're going to put your finger on that dot and literally just move it over to the right. So if we moved to the right, then follow the line over and then say to yourself, where does demand go? What's the silly rhyme that I've been telling you in your videos? Demand goes to the dirt. So I moved over to the right, and then I'm going to draw demand goes to the dirt. And so this one is demand curve one. And now, shockingly enough, if you can believe it, we're going to name this new curve D2, because that is demand curve number two. And I did already draw it when I was making the example, but when you draw demand curve two, your demand curve and shift is not complete unless you draw an arrow. You will not get credit without the arrow. And when you're drawing your arrow, don't draw it up like this. Really make a point to draw your arrow aiming to the right, like increasing on the number line would move to the right. So, population boom, we have more people. More people are going to demand more hamburgers overall, regardless of the price. This is not anything into consideration about how much the price of the actual hamburger is. There's just more people, therefore, you're going to have an increase in demand. So the whole curve shifts to the right. So, what is the shifter? It is the number of buyers. Okay, the next one. We have incomes fall due to a recession. Recession equals bad. I know we haven't talked about recessions yet, but I think you're old enough to know when you hear the word recession, that's not a good thing. That is a bad thing for the economy. So if we have a recession and people's incomes have gone down, then we're going to ask ourselves, if people have less money, are they going to buy more hamburgers or are they going to buy fewer hamburgers? In general, people are probably going to buy fewer hamburgers because they don't have as much disposable income. Maybe they'll eat a peanut butter and jelly sandwich instead if they are really short on cash. So, is this going to make more or less? Well, this is going to make people buy fewer or less hamburgers, which means we are going to be shifting to the left as a decrease. So, same thing, take your finger and put it on the dot and then shift to the left. So, after you move to the left, then where does demand go? Demand goes to the dirt. So, I think it helps if you make this little sound. Doot, 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 doot. When you draw your line, whatever. You don't have to make the sound. I can't hear you. But for me, when I draw the line in my head, that's the sound that I make. Now, this is demand curve one. I label it demand curve one. This is demand curve two. I label it. When you're drawing these graphs, you draw the axis, you label it. You draw the curve, you label it. You draw your shift, you label it. And the way that we label the shift is with the arrow. So which direction did we shift? We shifted to the left, indicating a decrease in demand. And this is the finished product for us. Number three, the price of tacos, a substitute good, decreases. Let's say it's Taco Tuesday and tacos are $1. So if it was lunchtime and people are getting out from their jobs and they're going to go have lunch, and you have the option to go get a hamburger for $12, or you can go get Taco Tuesday. It's Taco Tuesday, tacos are $1. People are going to go buy tacos. These are what we call related goods. There's two categories of related goods. You have substitute goods where I could buy Coke, I could buy Pepsi. There's substitutes for each other. I could buy hamburgers. I could buy hot dogs. There's substitutes for each other. I could buy a Toyota. I could buy a Ford. There's substitutes for each other. So they're products that you could buy one or you could buy the other, and they could go back and forth. Then there are what we call complementary goods, which are things that you buy together. And the classic example of that is like peanut butter and jelly, or shampoo and conditioner, or I don't know, donuts and coffee. Like there's an unlimited supply of food related complementary goods. For non-food related, you could think like maybe a gaming console and then purchasing games for that gaming console. So you could buy an Xbox and then you have to purchase the game separately. Those are complementary goods because they complement. You buy them together, shoes and socks. Lots of examples of things that we could come up with. So in this case, these are substitutes. So are people going to buy if tacos are on sale? Notice that we didn't say that there was a change in the price of the hamburger. The hamburger is the same price. The hamburger was $10. It was $10 before Taco Tuesday. It'll be $10 after Taco Tuesday. So this is not dependent on the price of the actual product. Notice that all of these graphs are graphing hamburgers. So we're not worried about the price of the hamburger. In this case, there was a change in price for a related good. So, what happens to the demand for hamburgers? Well, I'm not going to buy a $10 hamburger if I can come over here and buy a substitute taco for $1. Honestly, I'd probably buy the taco either way, but that's just me. So, what happens to the demand for hamburgers? Well, fewer people buy hamburgers because a substitute product has a cheaper price. And so, we're going to show a decrease in demand. Same thing. Put your finger in the middle of your demand graph and a decrease in demand shifts to the left. So move your finger over to the left And then we say to ourselves, where does demand go? We moved over to the left. Demand goes to the dirt. This is demand curve one. This is demand curve two. And we indicate our arrow for the direction of the shift moved to the left. Okay, let's erase. And I am not gonna scroll down. I'm just gonna keep working with this same row of three graphs, but you guys are gonna go down to the second row of graphs on your paper. It just makes it easier for me. So again, I'm gonna come over here and I'm gonna label price, price, price on my y-axis. We already have a Q, but if you were drawing this from scratch, you would put a P and a Q to start your graph. And then you would draw a demand curve to start your graph. So number 4 is a trick question. Number 4 says the price increases to $5 for hamburgers. Now, let's assume before the hamburgers were $3. I don't know where this worksheet was thinking you were buying a hamburger if it was only $3, but okay. Before it was $3, now it's $5. This is a trick question because I'm going to say it again. I've said it before in the little announcements, but everybody repeat after me. Price doesn't shift the curve. This is a change in price of the actual product that we are graphing supply and demand for. This is a supply and demand curve for hamburgers, and the price of a hamburger changes. A change in price causes movement along the existing demand curve. Literally, the demand curve is a visual representation of the combinations of price and quantity. So if price changes, all we have to do is move to a different quantity on the existing curve. So where were we starting? We were starting off here. Let's just pretend like it was $3. So we were here at the price of $3. What does it say happened to the price? The price went up. So let's show it. Here's our new price of $5. At the price of $5, you only have 10 hamburgers being demanded. So again, this language is tricky. I am not the boss of vocabulary for economics. I think there's a lot of really terrible vocabulary in economics. The most terrible vocabulary in economics is the difference between demand and quantity demanded. Economists are not very creative. I'm not in charge of that, but I can at least try and help you navigate the vocabulary. So, this is not a change in demand. When the curve actually moves, that is a change in demand. This is a change in the quantity that is being demanded or a change in the quantity demanded. So, at $3, notice that we were at 30 units demanded, but when the price went up, now we only have 10. So how do we indicate this change on the graph? We just do it like this. The price went up. This is price number one. This is price number two. So all that happens is you move from one point to another on the existing demand curve. And what do we write for the shifter? As a trick, no shift, because it's a trick question. And number 5, there's a new health craze, no ground beef. I could probably more easily envision at this point an only eating ground beef health craze. But for the purposes that they gave us in this example, we are going to say that we have no, people don't want to eat ground beef. I don't know. And it gives you mad cow's disease or some crazy thing. Okay. So what shifter is this? Well, this is T for taste and preferences because I would prefer to eat something other than beef. This is not any other thing other than this. What do people like? What do they like? What do they not like? And right now, what this problem is telling us is that people don't like beef. They don't like hamburgers. And so if they don't like hamburgers, are people going to buy more hamburgers or are they going to buy fewer hamburgers? Well, if the what is hip and trendy is to eat more chicken and not hamburgers, then we're going to see a decrease in demand. The whole curve is going to shift because it doesn't have anything to do with how much the hamburger costs. It's just that people don't like it. They don't want it. It is their taste and preferences. I would prefer to eat something other than ground beef. So that means we're going to move to the left. So again, put your finger, shift to the left. And where does demand go? Demand goes to the dirt. And I make the sound. Do, 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 do. There it goes. Demand 1, demand 2. And you're saying, Mrs. Thies, we've drawn a lot of decreases in demand. Sure have. I guess that's how the cookie crumbled on these examples. Maybe the next one will be an increase in demand and we can practice shifting the other direction. Okay, number 6. Hamburger restaurants announce that they will significantly increase the price of hamburgers next month. I don't know. Let's say that there's something that is happening that is going to cause a supply shortage or something's happening that is going to make the price of hamburgers go up. So if I know right now a hamburger is $10, but next month a hamburger is going to be $17, I'm probably going to buy my hamburgers now. This happens all the time with gas. You've probably been playing the gas game for quite a while. Every time something happens in the news with the war in Iran, people go, "Oh my goodness, that thing is going to cause gas to go up." So what do? They go out and they buy gas right this minute because I want to get it before the price goes up. Everybody does that. Everybody tracks and says, well, if I think it's going to be expensive later, I might as well go ahead and buy it right now. So if I think there will be a change in the price in the future, it is going to affect my behavior right now in the present. So if it's going to be more expensive in the future, I'm going to buy it now. More people are going to buy it right now, which means we will have an increase in demand. An increase in demand shifts to the right. So put your finger on your graph, move your finger to the right, and then say to yourself, demand goes to the dirt. And we go do, 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 do. Here is demand curve 1. Here is demand curve 2. Draw the arrow, and that is an increase in demand. What is the shifter? The shifter is E, expectations of price. Oh, we didn't do the shifter for the one before. The one before, we said it, but we didn't write it down. Remember that number 5 was taste and preferences. Okay, let me erase and let's do our last couple of ones. The next one says that French fries, a complementary good to hamburgers, that the price goes up. I don't know why. Something has happened in the French fry market that has caused French fries to become much more expensive. So if you buy French fries and hamburgers together, if French fries are more expensive, I'm going to buy fewer hamburgers. This works a little bit better when you're talking about things like cereal and milk. If cereal is more expensive, people are probably buying less milk. Pancakes and syrup. If the price of pancakes goes up, people are probably buying less syrup because I'm not buying the expensive pancakes, so I don't need the syrup to go with it. So when the price of a complementary good, this is a complementary good, when the price of a complementary good goes up, the demand for the other good goes down. So French fries are more expensive, therefore people are buying fewer hamburgers, which means we shift to the left. D1, D2. It's not finished until you draw your arrow and make sure that you have your P for price. That is a terrible arrow. Good thing I'm not an art teacher. Okay, last one. Restaurants lower the price of hamburgers to 50 cents. Let's say it's like, I don't know, Throwback Thursday or something in there. For whatever reason, having some sort of promotion. Ballparks do this all the time where it's like dollar hot dog night or something like that, where they are intentionally lowering the price. They know they're going to lose money, but they're hoping that the number of people that it draws in, they'll buy a bunch of other stuff, and then as a result of that, they'll still end up making a profit. So in this case, the price of hamburgers goes down to 50 cents. Again, this is a trick question because we are changing the price of the actual thing that we are graphing. And so if we were at, let's go back to our price. We started at $3 for a hamburger, and they lower the price way down here to 50 cents for a hamburger. We do not have to draw a new graph. We simply have to say that this is price 1. And here is our new price number 2, or kind of extend our little curve, and then draw an arrow that way, showing price number 1. We've changed the price. Now we have a new quantity demanded for hamburgers. Okay, I hope that this helped. You have a second practice worksheet for you to try and do some graphs on your own, and then we will move on to supply. Hope you guys have a good night.